Hello, civil engineers. Welcome back to the lecture. So now what we'll do, we'll go to this particular beam. Okay, these two beams are left for us, isn't it? This beam, the beam number, this one, that is along grid 2 and along grid 3. So one thing, like I mentioned you in the previous lecture, here everything is same. This center to center is 3250, 5525, 5525, 5552, 55525. Okay, 1000, 1000, 1670, 1670, 1670, 1670, 1000, 1000, 1670. You know what I'm trying to tell is everything is same. So instead of doing the BBS two times in the number of member, I'll put two. That's it. Very simple. Okay. So if you want, I'll take one beam from here. Okay. I think there is no changes. I'll not explain there. See what all things will happen. Bottom, you'll put a main bar. So 16 diameter 2 bar, 25 diameter 2 bar. So two times you'll do. Top, you'll put a 25 diameter 2 bar throughout. Then top left extra, you'll have a 20 diameter 2 bar. Top right extra, you'll have a 20 diameter 2 bar. And at this E junction, you have a straight bar. You have to add 1000 plus 500 plus 1670. At F junction, you have a straight bar that is top straight 1670, and this will be 500, and this is 1670. Simple. Okay. Same thing, I've done it here. I've written plinth beam along grid D2 and G2. Here, I did not write number 2. Now I'm doing number 2. Okay. Because two times along grid number 2 and along grid number 3. So instead of doing your BBS two times, so you have to be smart now. So just put 2 here. Okay. The moment you put 2, all the steel will be calculated 2 times. That's it. Because end of the day, I require this thing here. Even the stirrup also 2 times you have to do. Done. Finish. Okay. Yeah. See now, whatever I explained. So your bottom 25 diameter, I have done the calculation. Okay. Then bottom 16 diameter, I have done the calculation. You see the answers, note down the answer. Later you can verify your answers. I won't be sending you the Excel sheets, because if I send you the Excel sheet, you will work on this only. So you prepare your own Excel sheet. Don't message me for the Excel sheet again. I won't send you. But if you want for any answer clarifications of the answers and all that, I can help you out. Okay, fine. But Excel sheet, I won't send you. Yeah. Then this is top main bar 25 diameter, because here we have 25 diameter. You see 25 diameter, 25, 25, 25, 25, 25. So that is why only one time. Top main 25 diameter I have done. This is a cutting length what I have got. All these things I have got. And then top left extra at D junction. This is top left extra. Then we have top right extra. And then this is your middle portion bar. Okay. This is at junction, E junction. So this is my E junction. Okay. So it is 1000, 1670 plus 500. So it's same thing, 1000, 1670, 1000 plus 500. And at this junction, it is 1670, 1670 and 500. It is at junction F. So this is at junction F, 1670, 1670, and this is 500. Same thing I've done it, 1670, 16500, and everything I've got the answer. You have to get the same answer. Okay. Yeah, here I've got. So only the thing is number of member I've done 2. That's it. Finish. Once you do everything, the complete steel will come here. I haven't done that calculation, but that later I'll tell you. Done. So finish. Now what we have done, all the BBS for this thing, this BBS we have finished now. This complete beam I've done. This complete beam BBS I've done. This complete beam BBS I've done. Now we'll go vertically. Which one? This will do. This will do. This 3. This is 4th one. This is 5th one. This is 6th one. And this is 7th one. Okay. So 7 beams are there. For that, you have to look for grid number A, 1, 2, and 3. So for that, what I'll do, I'll take you to this part. See here. So this is the plinth beam details. This is that. Okay. Grid C, grid A, B, and 3. Even though your beam is like this, a cross section they have shown like this. That you know. Okay. If you are still confused, for a person who doesn't know that, let me clear that for you. Okay. See. This is how it is. Okay. So this portion and this portion is here. 1. Okay, where it is? Yeah. This 1 is 1 here. This 2 is 2 here. And this 3 is 3 here. Okay. Got it? So this thing for this beam. This one for this beam. This one for this beam. Got it? In this way it is given. That much you can do. You just have to come here. This is not required for me now. Yeah. So one thing you need to understand. Now look at the beam dimensions and the beam reinforcement and all. If you observe carefully, this particular beam, Which one? This beam, this beam, this beam, this beam, and this beam. Everything is same. So what do you mean by same? 3770, 3750, 3750, 3750, 3750, 3750, 3750, 3750, 3750, 3750. Distance is same. Here, I think I should increase the size a bit. I'll increase the size, okay? Yeah, now it is okay. Fine. Okay, fine. Next, see, 25 to 25 diameter 2 bar, 1250, 800. 25 diameter 2 bar, see, I mean 25 diameter 2 bar and 20 of 2, 20 diameter, 25 diameter 2, 20 of 2, 1250, 800. 25 to 20 of 2, 1250, 800. 25 of 2, and I mean, yeah, 25 of 2, 800. This is 25 of 2, 16 of 2, 800. You're getting my point. Everything is same here. One thing is there is small change. The reason is, see here. This is 25 of 2, 25, 20 of 2, but here it is 25 of 2 and it is 16 of 2. But I'll consider that this is same. The reason is I'll explain you later, but I'm considering that. Okay, getting my point. You check everything. You take this as a kind of assignment. Okay, take a screenshot or take a image or whatever you do. Check this particular beam, check this particular beam, check this and this. Everything is same. This center to center distance 800, 800. Here also it is 800, 800. Okay. Then 25 of 2, 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 25 of 2. Then this is also 25 of 2, 25 of 2. Here also it is 25 of 2, 25 of 2. Everything is same. So what I'll do, I'll say number of member will be 1, 2, 3, 4, and 5. I'll do BBS of one beam. I'll multiply it by 5 so that I'll get the BBS for all the 5 beams. Got it? Great. So what I'll do, I'll go back to the Excel sheet. Already I've done. I've written here. Plinth beam along grid, A grid along grid. What is that? Yeah, along grid ABC. I want to. It's not ABC, no. It is along grid. Yeah, yeah. It is along grid A, B, and C, and this is and along 1, 2, and 3. Okay, this, and this I've written in this way. So I've written it here. Now, first will be your bottom main bar, which is 20 dia. Then will be your top main bar 25 dia. Then your top left extra at junction, straight bar at junction 2, top right extra at junction 3. Okay, you're getting my point, no? And here only the change what you're supposed to is number of member 5, 5, 5, 5, and 5 I have done. Otherwise, what would have happened? The same thing you should have copied 5 times and you should have done the calculation. And finally, you would have got the same answer like I'm getting. So instead of that, come to the number of member, make it 5. You'll do the BBS of 5 beams simultaneously because bottom diameter, top left extra, top right extra, stirrups, everything is same. So that is why I've done the same thing. Now you are in a position to understand this. Again, I won't teach you. Okay. If you still have doubts, you can get back to me anytime. Okay. I can make a separate session for that, or I can help you out with that calculation. Now, one thing you asked me that, sir, everything is correct, but you told that, see, sir, this is 25 of 2, 25 of 2. Like here, 25 of 2, 25 of 2, 25 of 2 is correct, sir. And this is also 25 of 2, sir. But here it is 25 of 2 plus 16 of 2. Here everywhere. So this is a different, no? Then why do you consider in this? Now, if I again, if only for one small changes, I need to do my BBS again. Instead of that, we don't have problem. Even though I'm doing a small change, instead of 20 of 2, I'm putting 6, instead of 16 of 2, I'm putting 20 of 2. How much change of steel will happen? 1 kg, hardly 1 kg. For 1 kg difference, if you create an Excel sheet, it will be a very long thing. Okay. So like always tell, again, it's the estimate we are doing. Okay. So no problem. You can consider that. But if there is so much variation, like if this was 25, 25, 25, and if this was 20, and your bottom, if it was instead of 4, if it was 2, then I would not have considered because there will be a huge variation. But here, only the problem is coming in the top left extra. This top left extra, this is top left extra, and top right extra. Okay, what is happening here? It is 20 diameter, here it is 16 diameter. This is also 2 number, this is also 2 number. Here it is 20 diameter 2 bar, here 16 diameter 2 bar. So for the sake of 2 bar, there won't be huge variation. And the length is also same. See, 1250, 1250, 1250. That is why what I did, I consider that in the same thing. Okay, I always tell you, this is the estimate we are doing, and it's okay. For example, when you do such thing, whenever you do estimate, like I told you, suppose if somebody comes and asks you how much kg of steel is required in my entire beam. So you did a calculation something like this, and you told them like we require roughly, I'll tell you, we require around, let us say, we require around 1.5 ton of steel. 1.5 ton of steel is required. You did calculation something like this, like I did, okay, where instead of taking 16, you took this thing, and it's okay. And when the real execution happened, almost 1.4 ton steel got consumed. So the client will be very happy because initially had that 1.5 ton of the steel would have gone, but in real practice 1.4 ton has gone. Around how much? Around 1 ton is saved. He will be happy. Now, when you do the estimate, if you had given that 1.2 ton would have gone, now I'll tell you one more case. I'll do one more. I'll do one more. Let us consider, instead of that, you told the contractor, you told the client that 1.4 ton is required for all this plinth beam execution. But practically on the site, 1.5 ton went. So that means 1 ton extra went. Then the client will be sad because you told 1.4 will go. Now in practically 1.5. So initially he will have only that 1.4. The whatever you tell initially, that thing he'll have in mind. So that is why when you do estimate, try to do a little overestimate. Never do underestimate. Okay, if you do underestimate, problem is later you'll face the problem. So that is why I'm okay with that. Instead of taking 16 diameter, I've taken 20 diameter. I'm on the higher side only. I did not do the lower side. I'm on the higher side. It's okay, doesn't matter. But never underestimate it. It's something like that. Like I explained. If you tell your client that total house will be constructed in a 50 lakh rupees, 50 lakh rupees, and if you finish the construction in 47 lakh, the client will be very happy. He'll feel like, okay, I've saved 3 lakh rupees, right? Now, if you tell that I can finish your home construction in 47 lakh rupees, and later in the real execution, if you actually spend 50 lakh, you'll be like, oh, 3 lakh excess I have spent. Actually, he didn't spend 3 lakh excess. The cost itself was 50. Since you underestimated the budget, since you underestimated the estimation, the client has to suffer. So whenever you give estimation and all, give it little on the higher side. You don't have to be so much accurate here. Now again, if you do this, it will take long time. Doesn't matter. You do this. Whatever I've done is correct. Okay, got it? Simple. So in this way, you have to do. And this is the answer. I'll just scroll it down. Just check the answer. Note down. Your bottom main bar 20 die will be this much. Then your bottom main bar 25 die will be this much. And your top left extra at junction 1 will be 59. Straight bar at junction 2 will be this much kg of steel. Top right extra at 3 junction will be this much. Okay. One thing you remember, when I did this calculation, no, I consider this as my junction 1. Okay. What I did is, yeah, where did it go? Yeah. So this is my left, okay? I consider this my left junction. This is my right junction, and this is my middle portion. Actually, if you look at the drawing, this one is on this side. You're getting my point? This one, no? If you check the drawing actually, but answer won't change. Answer remains the same, but just in case if you try to match the value, a left answer may come on the right answer may come on the left. I'll tell you. See, wait. And now I'll come here. This one, no? Yeah. Hmm. Yeah. See, this is one. Your one is here. Two. Your two is here. Three. Your three is here. Okay. And this is A. So according to this, this will be your left one, right? Where is your one? One. So this is your 1 point. Two is here. And this is 3. So if you look at this beam from here, this becomes my left, this becomes my middle, this becomes my right, actually. But when I did the calculation, I took this as left. That means I took this is my left, this is middle, and this is right. That is what I wanted to tell. Okay. You're getting my point. No, if you look your beam something like this, you say this is left support, this is middle, and this is right. But actually, this according to the cross section, the left is this one. Left is this one. I mean, this one is here. This is here. This is here. So I took this as left support. I took this as left. I took this as middle. I took this as right. Okay, that is what I wanted to tell. So I have done this accordingly. This is my left. This is my right. Okay, finish. You do it, you'll get the same answer. Yeah, and finally the last thing. Finally, which one did we leave? The last portion we have left, isn't it? Which is that last portion? I'll delete this. This one. We did up to here, no? This beams we have finished. This beam finish. This one is done. We finished even this one. Then I made you work on this also. All the 5 beams we finished. These 2 beams, that is at the D grade, D and E, 1, 2, and 3. This beam and this beam I did not do. That BBS I'll teach you now. For that, again, cross section it is given here. Okay. Where is that cross section? This one. Yeah. This beams. This beam. This one. This two. Why I didn't consider? Because here the change, there is a lot of change. It's a 20 diameter 4 bar. Here it was 25 to 22. No, this is 20 of 2. I mean, this is 20 of 4. This is also 20 of 4. And in the middle, it is 20 of 2. It is 20 of 2. 20 of 4, 20 of 4. 20 of 4, 20 of 4. 20 of 2, 20 of 2. 20 of 4, 20 of 4. And bottom also 800 and 800, 800, 800, 800, 800, 800, 800. And bottom is also how much it is? 20 of 2, 16 of 2. So here, yeah, here again, small change. See, this is 20 of 4. Again, this is 20 of 4. Again, small change is there. Here it is 20 of 2 and 16 of 2. Here it is 20 of 4 and it is 20 of 4. So what you'll do, you take 20 of 4 and do the calculation. Okay. Because you are overestimating. Otherwise, you have to do separately. Don't want, it's a small variation will come. It's okay. You club that. But don't do it for all the beams. Okay. Since we have, in order to reduce our calculation, I'm doing. Now you don't tell that, sir, this is nearby will club. That you cannot do. In worst condition, I'm telling. Okay, you can do because 20 of 2, 16 of 2. This is 20 of 4. No, so you do the calculation considering 20 of 4 here and here. Even though 16 is putting, you are going to put 16 here. You are overestimating a slightly by 1 or 2 kg. It's okay, fine. Rest all things are very similar. Okay, considering that, I'll go back to the Excel sheet and I've done the same thing for the last beam. Okay, where is the last one? Okay, where is the last one? Yeah, this is that last one. No, yeah, this is that last one. So I'll take this one. Okay, this last one we'll do it. Hmm. 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 Yeah, fine. So I'll paste it here. Come. Okay. So this is plinth beam. I've written bottom main bar. So bottom main bar is my 20 diameter. Okay. 20 and 16 I've done. So what I told you, I actually did 20 and 16. Now I observed that this is 2016, this is 20 of 4. So in that case, you have to make 20 of 4 here. Directly make 20 of 4 and this part you delete. You got the answer, no? Why I'm deleting? I'm little overestimating. Else I should have done two separately. And why I did that? No, because I'm multiplying. I'm doing for one. I'm considering that this and this is similar. I'm considering this beam and this beam have same reinforcement. Oh, wait, in that case, is no. Then we are yeah, fine. So I'm considering this and this reinforcement is same. So I'll overestimate only 20 of 4 only I'll do here also. Okay, that is why what I did, 20 I've written, number of member I put 2 and here I put 4 bar and accordingly 183 kg of steel is required. Okay, bottom is done. Come to the top. Top you are supposed to provide 20 diameter 2 bar. So come here, I've written 20 diameter 2, 20 diameter 2 bar and 2 member because for this beam and this beam I'll do simultaneously. Done. Next come to the top left extra. This is top left extra. It is actually 20 diameter 2 bar. So 20 diameter 2 bar, 2 numbers I have done. These things you know, it's observed. You can clearly see, okay. 1250, I have input 1250. Accordingly, I got 23.613 kg. Now, top right extra you come. So this is my top right extra. So this is my top right extra. So again, it is 20 diameter 2 bar. So I've written 22 and 2 number because for this also it will be calculated. And then the middle portion. This is middle portion. So straight bar at junction 2. This is my junction 2. So it is 3000. How did you get 3000? 1250 plus 1250 plus 500. Okay, 3000 you got. Finish. That's it. So again, number of member is 2. If I do for 1, this and this is 2. And how many? It is 20 diameter 2 bar, 20 of 2 and finish. That's it. And your beam also same thing. Beam is same everywhere. So you are very lucky that in this project your beam is same. That's it. Okay. Beam you have to do. Again, I've written number of member 2, number of member 2. Rest all things you can know how to do. You know how to find S1, 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 S1. I've done all these things. Okay. I hope if you still have doubts, you get back to me. I'll be there to help you out. That's it. Finally, complete BBS I've done. Now what I'll do, I'll write the weight of this that if I add all the 8 bar weight, I'll get how much? I'll get 23.9 kg. It is not 23, no? How much it is? Okay, it is just 23.9. Okay. Okay, so this is wrong. I think there is small this changes because this is not okay. Anyhow, I'll do it. Okay, I'll write sum, then I'll select from here. I'll select from here. I'll select all this eight row column. Select in this way till here. Okay, till here. Enter. Okay. 8 die itself is 502 kg. Okay, these things I'll delete. 8 bar itself is 502 kg for you. Okay, yeah. Now it will change, no? Since we added everything. Okay, correct. Okay, fine. Next 10 dia we did not use, so the answer remains 0. 10 dia we did not use. 12 dia also we did not use because we never use 12 diameter in the stirrup nor in any main reinforcement. So that also will be 0. Okay, that is why I've written 0 here. Okay, fine. Next come to the 16 diameter. So 16 diameter, we'll add all the 16 diameter. So 16 diameter, this is 16. Select like this. Select up to here. This is the last value. You should not select this also. This you should not select. Only the last value, whatever you got. So it is 232. Fine. Now come to the 21. So 20. Okay, 20. Everything is selected. In the 20 diameter, all the weight has been selected. Okay. You select it in this way, or you can add all these values. Fine. So you got how much? You got 1652 and 25 also I added everything. 25 also, all the things has been added. Yeah, so in 25 also, all the 25 diameter weight has been added. And in 32, we never use, so I made it 0. Okay. So in this way, I require 502 kg of 8 steel. I require 232 kg of 16 steel. I require 1652 kg of 20 diameter steel. I require 1436 kg of 25 diameter steel. And if I add all these things, 502 plus 232, 1652, 1436, I'll get 3823 kg of a steel is required, which comes out to be how much? 3.823 ton. So the same answer I have done here. Total rebar quantity in the beam is 3.823 ton. Got it? So you also should get the same answer. Even if you get 4 ton also, it's okay. Even if you get your answer close to 3.6 to 4 ton, also it's okay. Okay, ton. Or if you get 3600 kg to 4000 kg, also your answer is correct. Slight mistake you may have done, or maybe while I'm explaining somewhere in the Excel sheet, something may happen. Okay, that is why I always tell Excel sheet one time I've done, I taught you. When we do the billing and all, then we try to verify once again whether we have done proper calculation or not. But 95% of the case, the calculation is correct. Sometime I always mention you while inputting the value instead of 2, maybe in a hurry I might have done 1 here. So slight that variation will happen. Slight variation happens. See, slight variation will happen. That is okay. That is very natural. See here. So instead of in a hurry, we didn't do wrong. In a hurry, instead of that, I made one member. It came out to be 3.778. Actually, it should have been how much? 3.8, 100 gram variation has come. So in that way, that slight mistake will happen. It's okay. That is why I'm giving 3.5 to 3,500 to 4,000 if you're getting the answer. It's a, but you should not get 2,500 and all. That means severe mistake you might have done. You should not get 2,500 the answer. That means almost 1,000 kg of steel is missing. 1 ton you're rough underestimated. You cannot do that. You should not get answer like 5,000 kg of steel or 5 ton. That means you're overestimated. You might have added some other extra values and all. So this is a range what I'm giving and it's okay. Again, you have to consider 5% wastage in that. Okay, that's it. Finish. So I hope you have enjoyed my lecture up to here. This complete thing, the complete BBS of a beam I've explained you. Okay. So in the further lectures, I'll be taking few other complicated beams, but the procedure remains same. But since I would like to make you, exposed to few of the other structural drawings, like right now we did it for a residential building. In the future lectures, I'll make you go through a few of the commercial building and also some industrial building. And also, if you remember, this residential building BBS I didn't do because it will be a very tedious task for me to do a BBS for this. But I'll explain you how to understand this drawing, like I mentioned in the start of the beam lectures. I'll explain you how to understand this drawing. then also I'll make you work on a few of this complicated beam BBS. But again, the concept remains the same. Got it? So we'll see you back in the next lecture. Thank you.